This is the first video in a series on sketching trigonometric functions. This video is going to look at basic graphs only. So to start with, you need to know what a periodic function is, and it's one where there is a regular pattern of rise and fall over time. A cycle is that section of the graph which repeats itself. The period is a length of time for one cycle. The amplitude is half the average distance between the top of the rise and the bottom of the fall. So if we looked at the graph that we have here, I start at the bottom, I go up, I go down, and I go back down to the bottom. I then keep repeating. So this is a periodic function where the period is the length of that one cycle, that is pi. So the period is pi. The amplitude, you can see that the graph goes between -3 and 3. So the amplitude is 3 plus 3 divided by 2, which is 3. Alternatively, you can think about it as being the distance between the midline and the top. Okay, so you can see this middle line through the graph. So let's look at the basic graph of y equals sine theta. If we go back to our unit circle, we know that sine theta is our y coordinate. Okay, so our y coordinate when our angle is 0 is 0. So sine of 0 is 0. Moving up, sine of pi on 2 is 1. Sine of pi is 0. Sine of 3 pi on 2 is -1. And then we're back at the beginning, sine of 2 pi is 0. So if we look at our graph, when our angle is 0, so we're looking at a graph of our amplitude y across time, which is x, or theta in this case. So I'll label the axis theta. So we're starting at 0, 0. Then we're going pi on 2, 1, pi 0, 3 pi on 2, -1, 2 pi 0. So if you join those dots, we get our graph. Now what would happen if we wanted the negative direction? So what's negative pi? Well, negative pi, we were at -1 because that's my y coordinate. So we're just going in this direction. Then we go to 0, then we go to 1, then we go back to 0. Making sure you put arrows at either end. That is our basic graph for sine theta. So the key point to remember with sine theta is that we start at 0, 0, up, down, up. Okay? The period of the graph is 2 pi. So the period, it repeats itself every 2 pi. And our amplitude is its highest point, 1. Let's look at our cos graph. Again, looking at our unit circle, cos this time is our x coordinate. So x coordinate for cos theta. So we go when it's 0, 1, 0, -1, 0, back to the beginning. So when we look at our graph, this time we start at the top. down to 0, down to -1, up to 0, up to 1. Join the dots. Now, if we went into the negative direction, we have 0, -1, 0, 1. Joining our dots. Find it a lot harder to draw backwards. And our arrows on either end. So here, again, our period is 2 pi. And our amplitude is 1. So the key thing to remember with our cos graph, for our basic graph, is it starts at the top and then down and up. So that is our basic cos graph. Now let's look at our tan graph. Remembering that tan theta is sine theta over cos theta, or y over x. So at 0, y divided by x is 0 divided by 1, so it's 0. At pi on 2, y divided by x is not defined. At pi, y divided by x is 0. And at 3 pi on 2, y divided by x is not defined. And then we're back at 0. Now, these not defined create what's called an asymptote. A part of your graph that is never touched, or a line that your graph never touches, probably a better way of putting it. We know 0 at all these points. Okay, if we went in the negative direction, we would have these asymptotes at the same points. Now, really need to provide some more information, but the graph goes through like so. And it would keep going. Okay, so one thing to notice here, if you remembered your exact values, tan of pi on 4 was equal to 1. I've drawn this pretty accurately because pi on 4 is halfway between 0 and pi on 2. So that's your 1. And that would keep repeating every pi. So you can see that there. Okay, so there is no amplitude, and our period is it repeats itself every pi.